Chapter 12 Capacitor. We are going to cover these sessions in Chapter 12, Electric Fields and Capacitance, Applications, the types of capacitors, the factors that can affect capacitance, series and parallel capacitor circuits. 12.1 Electric Fields and Capacitance. Capacitor is an electrical device that made of two plates. Most of the times, we put the plates in parallel. The plates are separated by a distance. Usually, we put the materials between the plates. These materials are called dielectric material, which are used to boost the capacitance, which is the capability for this capacitor to store charges. In short, capacitor is just an electrical device that can store electric charges. Here shows a picture of the simplest capacitor. As you can see, there are two plates. The two plates are parallel to each other. Between the plates, there's nothing inside, so that is air or vacuum. So the dielectric material for this simplest capacitor is air or vacuum. Each plate connects to a wire. The two plates are not connected. The plates are conductors. For example, we can make the plates using steel, copper, aluminum, as long as the material is conductor. For most capacitors, the plates are made of same material. The two symbols on the left-hand side are the schematic symbol for capacitor. The one on figure A is the general symbol, the simplest symbol. Most of the time, we use this symbol to represent capacitor. The second figure, figure 1C, that is capacitor symbol as well. But as you can see, the positive and the negative signs are labeled next to the capacitor, which means this capacitor has polarity. In other words, the orientation, the direction to connect the capacitor is important. The plate has the positive label. The positive symbol need to connect to the circuit has higher electric potential, which means higher voltage. So the other side, the negative terminal connects to the circuit, has lower electric potential, the lower voltage. When we wire the capacitor in a real circuit, we have to wire it correctly. Otherwise, there is a higher chance we will blow up this capacitor. The smoke comes out, you'll be toasted, it will be barbecued. So keep this in mind. Now let's look at the simplest capacitor again, but this time we're gonna add some materials between the plates. And I use green color to indicate this special kind of material called dielectric material, or simply dielectric. The reason we put these materials inside just to boost the capability for the capacitor, so it can store more charges, store more voltages. Let's look at this circuit. As you can see, there's a capacitor connected to a source. Between the capacitor and the source, there is a switch. Initially, the switch is open. Now let's replace this capacitor by just a 2D capacitor, the two plates. The plate initially has protons and electrons. Let's assume the number of protons and the number of electrons are same initially, so there's no net charge in either plate. As soon as we close the switch, this circuit is closed. So electrons start to flow from the negative terminal towards the positive terminal. Electrons are flowing out from the negative terminal and then continue flowing, more electrons flowing towards the plate. And then now electrons entering to the plate. More electrons are accumulated and enter to different regions on the plate. But those electrons cannot penetrate because it's air, the insulator between the plates. It just cannot flow from one plate to the other side. So once electrons enter into a plate, such as here, the plate on the right-hand side, these electrons attract the protons from the other plate. At the same time, these electrons push the electrons on the other plate. The protons on the other plate are closer to these electrons than the electrons on the other plates. So the attraction force is stronger. So imagine if we can use hands just to grab the two plates, and we want to separate these two plates by hand. We can clearly feel that attraction force, which means it's hard to separate the plates because there's an attraction force between the plates due to the electric force.